Hello everyone, I hope all of you are fine. So this will be our next chapter, that is motion in a straight line. A few concepts of this chapter you have already learned in the previous classes, that is in classes 9th and 10th, so I'll not be discussing those concepts in detail. Out of which the first one is distance and displacement. As we know that distance is the total length of the path covered by the particle in definite time interval, and displacement is the shortest path. This we already know the difference between distance and displacement. Related to this, you have already learnt the concept of velocity, speed and acceleration as well. For example, this object is moving, if an object is moving from A to B and it is going via C. So if we have to consider the distance part, it will be A, C, B, and if we have to consider the displacement part, it will be the shortest distance between the initial and final position, that is AB. Okay, I hope you must have watched the videos sent by Dr. Kakkad, and he has already covered the vectors part of it. So vectors are something which have magnitude as well as direction. So this is the displacement in terms of position vector. Now position vector is something which can be suggested in terms of a point connecting with the origin. For example, this is the point A, x1, y1 and z1, so its position vector would be x1 I cap plus y1 j cap plus z1 k cap. Now I, j and k are the unit vectors in x, y and z directions correspondingly. In the same way, if I am trying to find the position vector of this point B, that is, it has coordinates x2, y2 and z2, so the position vector of B, that is RB, would be x2 I cap plus y2 j cap and z2 k cap. I am repeating it again. I means in terms of x, j cap means in terms of y, and k cap means in terms of z. So whenever I am trying to calculate this delta r vector means change in position from point A to point B, will simply subtract the coordinates of B from A, that is x2 minus x1 into I cap, y2 minus y1 into j cap and z2 minus z1 into k cap. So this will be the position vector for delta r vector, that is delta x I cap plus delta y j cap plus delta z k cap. Okay, next is, these are the few key points that are needed to be taken into consideration. First is, distance is a scalar quantity while displacement is a vector. This we already know. Distance depends upon path and displacement is independent of path but depends only on its initial and final position. This also we know. For a moving body, distance cannot have 0 or negative values, but displacement may be positive, negative or 0. How displacement would be negative? Some of you might be confused in this. For example, this is our starting point. We start from this point, that is O, and we move in this direction at first and we reach point A. Okay, after reaching point A, I start my journey in the opposite direction and reach this point, that is point B. So in this case, if I say that this rightwards direction is positive, so of course the leftward direction would be negative. Okay, so then we will say that displacement would be negative, Hana? So I hope this would be clear. And 0, of course, if we will end at this point, that is O point, the displacement would be 0. Okay, the infinite distances are possible between two fixed points because infinite paths are possible between two fixed points. This you must have understood. Only single value of displacement is possible between two fixed points. ये भी आ गया होगा समझ. If motion is in a straight line without any change in direction, then distance is equal to displacement is equal to magnitude of displacement. It means we are moving in only one direction, we are not changing in a direction, so that is why it will be motion in a straight line in this way. Okay, we will be moving along a single straight line and we will be starting from a point and we will be ending at a point. So in this way, the magnitudes of distance and displacement would be equal. Okay, so magnitude of displacement may be equal or less than the distance but never greater than the distance. ये भी समझ आ गया होगा, ठीक है? These are the few examples which can be taken into consideration while understanding the concept of this distance and displacement. So what we'll do is we'll simply take this question into consideration, that is a particle starting from origin, goes along x-axis up to the point 20, 0. As you can see that this has started from origin, that is 0, 0, and it is ending at point A, that is 20, 0. Returns along the same path, returns along the same line, that is to the point minus 20, 0. So we have to calculate the distance and displacement of the whole trip. Now this is very simple. We will be moving 20 units towards this side, and we have already moved 40 units towards this side. So distance would be 20 plus 40, that is 60. And in the same way, since we are moving only along the x-axis, so it will be measured in terms of I cap. Let's say this direction is positive and this is negative, so it will be 20 I cap positive plus minus 40 I cap. So the displacement vector would be minus 20 I cap. Okay, so this is a question you all can try. A car moves from O to D in this way. What is the distance traveled and the net displacement? For calculating the distance, you will simply add this 8 plus 4 plus 4 plus 1, and then for calculating the displacement, what you will do is you have to find this distance, and for finding this distance you need to find these two distances. If this would be 8, so this would be 4, and if this is 1, this would be 3. When we will apply this Pythagoras theorem, since this becomes a right angle triangle, it will be 5. Okay, so you can try this, and if you would be having any problem, we can of course discuss these in our doubt sessions. These are few more questions that you can try. I won't be reading these questions in detail. I'll give you a time. I'll give you few seconds to note down these questions. So these are the 4 questions that you can try based on the concept of distance and displacement. And if you would be having of course any doubt, we can discuss. Take into consideration this one thing, that whenever we have to calculate the distance, we need to take the whole path into consideration, and while calculating the displacement, we will be taking into consideration the initial and the final position. So keep these 2 points in your mind while solving these 4 questions, and then of course we can discuss these questions during the doubt sessions as well. So try this. They are based on the concept of distance and displacement only. Okay, now this is our next topic, that is acceleration. We know that the rate of change of velocity of an object is known as acceleration, means how fast an object is changing its velocity. Of course it is also a vector quantity. Its direction would be same in the direction of change in velocity. So the dimensional formula would be mlt minus 2, and units would be of course meter per second square, and these would be the SI units. Acceleration can be of 2 types, uniform acceleration and non-uniform acceleration. In this case we have only explained here the uniform acceleration, and we'll continue with the non-uniform acceleration in further. A body is said to have uniform acceleration if magnitude and direction of the acceleration remains constant. It means, for example, a body changes its velocity from 10 to 20 meter per second, let's say in 1 hour. Okay, in the same way it will be changing its velocity from, let's say, 20 meter per second to 30 meter per second in 1 hour, or we can say in next hour. So this is the case for uniform acceleration. Uniform acceleration means if the change in velocity with respect to time would be same, so such accelerations are known as uniform accelerations. Okay, this is non-uniform acceleration, of course, if either the magnitude or the direction or both change during the motion. So average acceleration would be a ratio of total change in velocity upon total time. For example, if the velocity at the starting part was, let's say, 10 meter per second, and velocity at the ending part was, let's say, 50 meter per second, and the whole journey was covered in, let's say, 3 hours. So what will be the average acceleration? That is 50 minus 10 upon 3. So it will be 40 by 3 meter per second square. Okay. Next is instantaneous acceleration. Instantaneous acceleration means it is the acceleration of the particle or at a particular instant of time. Whenever we use this term, that is the instantaneous, it only means at that particular instant or at that particular moment. So you need to keep this thing in mind that instantaneous acceleration can be denoted in terms of this aspect, that is dv by dt. We know that velocity can be expressed in terms of position as rate of change of position with respect to time, means dx by dt. So acceleration can be expressed in terms of velocity as dv by dt. Okay, so in other words, acceleration can also be expressed as d2r or d2x by dt square. It means the second order derivative of position with respect to time. So it is read as d2r by dt square. So this is the concept for acceleration and its various types, that is uniform, non-uniform, average and instantaneous. So go through this content once again if you feel any doubt, and we'll continue it in the next video. Thank you.